Here are your examples for Lesson 3 in Chapter 4, Functions. Functions is a new term, so the first thing I would like you to do is put something about this in your notes, this table right here. Functions. To find the value of a function for a certain number, substitute the number for the variable x. First thing I want to talk about is how we say this statement here. As they say down here, this can be read f of x equals 15x. And one of the things I want you to recognize is that we could just turn this into a statement that we're very familiar with and make it y equals 15 times x. And it becomes very familiar. So all we're doing is we're changing the terminology here. We're going to read this as f of x equals 15x. Just like in this situation here, y equals 15x, x is the input, and as it states here, it is the domain. And the output, y, which now becomes f of x, is the range. So let's take a look at this further now that I cleared that so you can see this better. Remember, your input, x, is the domain, and your output, as we were calling it before, y, which now is f of x, represents your range values. This is an important concept. Please put that in your notes. Now let's take a look at example number 1. They ask us to find, remember the way this is stated is f of negative 3, so we're going to find f of negative 3 if f of x equals 2x plus 1. So we'll put that over here, f of x equals 2x plus 1. And again, we could rewrite that as y equals 2x plus 1. And now when they say that f of negative 3, what they're saying is we need to put negative 3 in for the x value, as they did right here. So we have f of negative 3 equals 2 times negative 3 plus 1. 2 times negative 3, of course, is negative 6. Add 1, and then we have negative 5. So the way we would state our answer is f of negative 3 equals negative 5. If we take a look at what you already know, if I were to tell you that y equals 2x plus 1, find y when x equals negative 3, you would just multiply 2 times negative 3, add the 1, and you would get negative 6 here, plus 1, and of course you would end up with an answer of negative 5, just like we did over here. The only thing that we've really changed is we're referring to it as f of x, or the function of x, instead of y. In both cases, they're outputs. Please press pause and do letters A and B. Okay, the next concept that I need you to put in your notes and also on your gold sheet, it is the concept of a function table. You can organize the input, rule, and output into a function table. Now what they're saying there is that the input is going to be the domain, or the x values. The rule, of course, is the algebraic expression that we're using. In this case, it's f of x equals x plus 5. And then, of course, your output is referred to as f of x here, but we can consider that as virtually the same thing as y, and it should be very easy to understand. So now, taking those things into consideration, let's finish the rest of this important concept here. You can organize the input, rule, and output into a function table. The variable for the domain, remember, is the independent variable, and I'm going to draw a line over here. So remember that the domain is the set of x values. So we can look at the independent variable as the x values, because that can be any number. The variable for the range is called the dependent variable because it depends on the domain. And remember, that would be f of x, or our y values. Now let's take a look at example number 2. It says to choose 4 values for x to make a function table for f of x equals x plus 5. So we're going to have a domain, we're going to mark that x, and we're going to come up with some inputs. In this case, they use -2, -1, 0, and 1. And then we're going to have a rule. The rule is f of x equals x plus 5. And then we're going to calculate the output, which is f of x. So in this case, we're going to use negative 2. So we substituted for x in the first one. So we have negative 2 plus 5, and of course that is positive 3. Then the next thing we do is put negative 1 in as an input. So now we have negative 1 plus 5, and that of course is 4. Next we use 0. So we have 0 plus 5, that's 5. And then lastly 1 plus 5 is 6. So with these 4 inputs, we end up with these 4 outputs, or f of x values. Now the last thing they ask us to do is to state the domain and the range. Well, remember the domain is right here, and we listed least to greatest. So we have negative 2, negative 1, 0, and 1. Right here is our domain. And remember, when we do domain and range, we are always going to use our brackets before and after. Lastly, the range is our output values, and you can see that that's 3, 4, 5, 6. So right here is our range. One of the things I need you to do is when you do letter C, it says to choose 4 values. Well, in order for it to make it easy for us to correct, and also for you to check your answers with the next video, I would like you to use these values, negative 1, 0, 1, and 2 for your inputs, or your domain values, your x values. Please press pause and do letter C. Problem number 3. There are approximately 770 peanuts in a jar of peanut butter. The total number of peanuts, that would be P of j, is a function of the number of jars of peanut butter, j. It asks us to identify the independent and dependent variables. Since the total number of peanuts depends on the number of jars of peanut butter, the number of peanuts is dependent on how many jars we intend to fill with peanut butter. So the jars of peanut butter, or j, is the independent variable. It is the input. We're going to input number of jars we want to fill, and that will give us our output, or the dependent variable, P of j, how many peanuts we will need in order to make enough peanut butter to fill those jars. Example number 4 says what values of the domain and range make sense for this situation. This is an important concept here, because this is going to tell us, it's going to determine whether or not we draw a line when we graph a function, or whether we just use a series of points when we graph that function, because sometimes values for the input do not make sense, and this is the perfect example of that. Only whole numbers make sense for the domain, because you cannot buy a fraction of a jar. The range values depend on the domain values, so the range will be multiples of 770, because we're putting 770 peanuts in every jar, and we're not going to have a jar and a half. We can't have a number like 950 peanuts. It does not make sense. Okay, example number 5. Write a function to represent the total number of peanuts, and then determine the number of peanuts in 7 jars of peanut butter. So the first thing we need to do is come up with an equation, and remember, we can go back to what we talked about in the last chapter and early part of this chapter. We're always going to have an output equals the slope times the, so now translating that to what we have in this particular problem here, input is going to be jars. That's going to determine how many, and our slope is 770, because it's 770 peanuts per jar, and that will give us our output, P of j. It's going to tell us what we end up with for the number of peanuts we need. P of j is our output in peanuts. So now let's take a look at this back over here. So the function P of j, we could consider that in our old system. We wouldn't use y here. We could say y equals 770x. That's the way we originally started. But remember, we started talking about how let's start using letters here that let us know specifically what we're talking about. In this case, it would be peanuts equals 770 times jars. So using P and J makes more sense here. So now if we go to the function form of doing this, instead of saying output in peanuts, we're going to say P of j equals 770 times J. That represents our situation here. And then now we have an equation. All we need to do is look at our problem, and it asks us, okay, what is the situation if we use 7 jars, or we need 7 jars of peanut butter? So we're going to have P of J equals 770 times J. P of J, therefore, is 770 times 7 because we need 7 jars. Multiply 770 times 7, and we get 5,390. There should be 5,390 peanuts in 7 jars of peanut butter. That is our output, 5,390. Please press pause and do letters D, E, and F.